Hello, everybody. Welcome to our weekly OPI Lifecycle Provisioning Technical Work Group. Today we have a very good agenda. We'll start with Samer from ARM on the Secure Boot, Root of Trust, TPM device attestation standards for DPUs, following by Daniel about the SMBIOS validation tools. And you can see it in the chat. I published the agenda as well. So, Samer, take us away.
All right. So what I will probably start with, and let me share my screen here, is maybe going over the base boot security requirements that apply from ARM to all standard systems. And we are including these requirements for all DPUs that want to be compliant with the ARM standards. The good news is that most of the requirements in this specification are derived from industry standards. So Secure Boot, UEFI, authenticated variables, TPM, as well as a checklist that is added at the end of the specification that covers some of the guidelines for root of trust and secure device implementation. So I will go ahead and just I will go through some of the sections here, and we can do as deep dive as we'd like on specific requirements. And if anyone has any questions, please let me know. This document is public and available on the ARM website, and a lot of the basically pretty much all the DPU vendors we're working with are aware of this, and it's part of a number of other requirements that we have. This one is specifically about security. In future agendas, I would like to discuss other requirements related to firmware in general.
So, Samer, that's good. I think that eventually we'll need to take a link and publish it on the OPI website. If this is the guidelines or the standard that we or several standards that we're currently following. So let's do the
okay. Yeah, I'm open for any feedback, and these standards get updated over time with consultation with all of the ARM ecosystem partners. So we work with all of the DPU vendors, and if we see something here that we feel strongly about, we're open for changes, adding, removing, etc. So these are evolving, not written in stone, but so far they have proven to be very good starting point. And I should also add that we have a certification test suite that go along with these standards. So a set of open source test tools that you can run on the DPU in UEFI and in Linux on the DPU, and they will verify that all of these rules are properly implemented. So if you have TPM or Secure Boot, for example, we have specific tests for those to ensure compliance. So that's at a high level. I'll go ahead and I'll start going through some of the details, and please stop me if you have any specific questions. The first group of requirements is around UEFI authenticated variables. So these are essentially pointing things that are in the UEFI spec that are generally optional by UEFI. But if you are going to implement UEFI Secure Boot, you need a foundation in the UEFI variables that ensures those parts of the UEFI specification are implemented. So the rules are divided into groups and described in tables. Every rule has an ID that we refer to when testing and doing certifications. And whenever the rule refers to external industry standards, like the UEFI specification or other standards, there are specific references as well. So first rule is authenticated variables must be supported, and refers to specific UEFI sections. There is a rule then about having some amount of non-volatile storage for UEFI variables that is free and available. This rule was actually derived from similar rules that exist on servers across the industry. Originally started by Microsoft for running Windows with Secure Boot. But the theory here, the idea behind having this extra space is there is enough space to allow UEFI Secure Boot revocations to happen in the field. So this is allowing updating the UEFI Secure Boot DBX, which is for those of you familiar with Secure Boot, it's the database of forbidden images or forbidden keys and hashes, because as things get signed over time, signatures get revoked for whatever security incident, etc. So frequently the UEFI forum publishes updates to the DBX, the forbidden database, and those updates will require some firmware update to store those revocations in firmwares. Therefore, we have to ensure that devices are built with sufficient firmware space in the UEFI variable non-volatile storage to allow for these revocations to happen in the field during the life cycle of the device. The next rule is also about secure boot revocations, and this was created specifically to say, hey, if we do one revocation every few years and that revocation variable is large enough, there used to be issues in the field where, especially on servers, UEFI firmware could not write a large variable that's larger than like 8K or 16K. So the industry agreed on a rule that up to 64K seems like a reasonable size for one large update. So, and we do test for this rule as well. And finally, the last rule is just combinations of UEFI variables that is really following the UEFI spec. So nothing here is out of line from what the either UEFI spec dictates but leaves as optional, or what the industry norms are in designing servers. That's the first area of the foundation for secure boot in UEFI authenticated variables. Any questions on this one?
I guess one question that I have is, do we know that like all the DPU vendors that participate in OPI, how compliant they are with this, or do we need to run a test suit against them and publish the results? Like, what exactly is relationship between the DPU vendors and this spec?
I mean, we have several DPU vendors here on the code if you want to comment, but I can comment from our side. Let me share something just to show. Just wondering how much I can share. 1 second. So we do have existing ongoing relationship with several of the DPU vendors where we are doing testing against the firmware requirements and the hardware requirements to ensure that ARM-based DPUs can run OSs just like x86 servers or machines work without having to customize the OSs heavily. So general standard off-the-shelf distros. Of course, you need to add drivers or packages to make the software useful, but at least from a firmware point of view, things should just work. And I presented about that in the past about the ARM System Ready program and those base firmware requirements. So specifically with these security requirements, this is one step above the baseline of the firmware requirements and certification. So after we do base testing and certification of the firmware and the hardware, then we do additional testing and certification of what we call the security interface extensions. And at that point, we run the test suite that maps to all of these requirements, and we plan on publishing the results. At this point, we haven't published any results yet on DPUs using this test suite, but there is an ongoing activity there. Maybe we can come up with an action item to come back with some preliminary results, or if DPU vendors would like to comment or talk offline, I'll be happy to help with this.
I think that at least for this group, I think it will be available to see the results of that, whether they are published publicly by ARM or DPU vendors. I think that that will be helpful for OPI to see the compliance versus non-compliance in this space, both for the base and the security edition. Not sure if other people feel the same, but this is my kind of take on this.
I think that's a fair assessment. If OPI, if us as a group want to try to follow some of these guidelines or requirements and leverage the test tools that are available publicly for these, I can make a summary. Maybe we start a new page on specifically for security, and maybe another one about the firmware requirements. I know we have SMBIAS as a separate discussion, but if we have a place where we can track this in GitHub as an ongoing discussion, I can put pointers to the specs, pointers to the test tools, which are all open source and everything is public. And maybe we open it for feedback of individual DPU vendors to run these and comment on anything that they see there.
I like this idea. Let's take the action item and do that. Any of the DPU vendors, I see Intel here, Marvell here, AMD here. You want to comment on like this spec and publishing the results, or you want to take it offline and think about that?
I would say the spec makes sense. We should take it offline with respect to how to publish it.
Okay.
Yeah. That's Marvell's point of view also.
Okay, excellent.
I have a quick question, if you don't mind. So I'm sorry I missed the beginning of this. What's the relationship between this and the system ready standards?
This specific document, the BBSR.
Mm-hmm.
Yeah, this document is, I'm going to show you here 1 second, is part of the ARM System Ready certification program. If I open here this web page, which is the ARM System Ready certification program, there is a specific base certification for SmartNICs or DPUs, which is the System Ready ES. This certification tests for the basic UEFI, SMBIOS, ACPI, and silicon requirements. So that's the baseline. Then on top of that, there is an additional certification called the Security Interface Extensions, which uses the BBSR as a requirement list. It has an additional set of tests that are open source and gives you this additional certification for the DPU that it's certified as meeting the security requirements in addition to meeting the baseline firmware and OS boot requirements.
Okay, great, thanks. So like from a Red Hat perspective, you know, we require system ready certification to be able to support running RHEL on a device. And so this makes a lot of sense. The thing that I'm not familiar with yet is this security interface extension. So I need to do a little bit of research into that, but thank you.
Yeah, thanks, Stephen. I think if we do this GitHub page to start summarizing, at least from ARM's point of view, we can summarize all of this in short paragraphs and give chance for everyone to comment or add their questions there as well. This is very good start to discussion. Let me move on to more technical requirements if there's no questions on the first group. So the second group of requirements is about UEFI secure boot. Again, nothing here is out of the ordinary. All of this is based on the industry standards, UEFI, and the current OS's practices and support for secure boot. It is just distilled in very clear requirements that are testable that are part of that SIE Security Interface Extension Certification Program. So the tests, if any of you are familiar with the Windows hardware certification, for example, there's some maybe very similar approach to this that PCs and servers that get the Windows logo, they get certified by testing a large number of things. Some of those things include maybe UEFI Secure Boot. This is an approach that is in essence very similar to that, or Red Hat hardware certification or SUSE hardware certification. So from ARM point of view, this is like more foundational firmware security requirements that are OS agnostic. We do test them from Linux and from UEFI shell, but the interfaces can be tested from any OS if you would like. So the first rule is UEFI Secure Boot must be implemented, and it must validate against UEFI drivers, option ROMs, or applications. There must be some requirements from the UEFI spec that are met, of course, secure variables, secure boot driver signing, and the runtime services rules. There are requirements around preventing rollback, so to prevent against rollback attacks. If you have, for example, you know, some updates to the signature databases or to the forbidden signatures database, you want to prevent against malware that may roll back to a previous version that did not have those revocations. So there are tests for that. This is another rule around preventing rollbacks. The first one was against the DB, the allowed signatures database, and the second one is around the DBX, or the forbidden signatures database. There is a test around making sure that everything is verified against the UEFI Secure Boot image validation. And actually, as part of the tests that we have for this, there is some manual initial setup, and then it runs through an automated test suite. And the manual setup includes installing some test keys that we sign specific applications that are part of the test suite with those test keys. And then we will test, is a signed application allowed to run, an unsigned application is forbidden, an application that has a signature in the forbidden database is forbidden, and so on. So we will basically re-provision the certificates in the secure boot databases as part of the testing. We remove the defaults and re-provision them. And then at the end, after everything is done, we ask that they get reset back to their default state. There is reporting for auditing purposes. So there is you know, that failed components should not continue to load and execute, and there is some additional, I believe there was some rule here, I have to look it up, but there is some like additional, here it is, image validation. No, I'm sorry, I'm not able to find it right now, but there is a UEFI signatures table that is maintained by firmware that keeps an audit of all images that failed. So we will actually test, we will parse that table and test that what we expect to see there as failures are actually logged as for auditing purposes. And that's, I think, about it for Secure Boot. So really, most of the work in Secure Boot is not in the requirements, it is in the testing. There is quite a bit of work that ARM has put in creating open source, freely available test suite to validate that UEFI Secure Boot is correctly implemented.
As a group, do we think that taking that open source tooling, running them on GPUs, publishing the result makes sense, or not really?
There's a question of signal noise ratio. I mean, if this is if this is already in a standard someplace, just saying it's a standard in our case, does it add value or not? And that's probably the question to be answered.
It is mostly in a standard in the UEFI spec. The standard does not have a list of rules that say these are the 7 things that you need to do to properly implement Secure Boot. The standard is comprehensive and has all the optional bits and pieces. The closest place where something like this has been documented is for the Microsoft Windows hardware requirements for Windows logo certification. In the x86 world, whether it's PCs or servers, that has been mainly the driver that's ensuring firmware and system implementations are compliant with the UEFI spec. On the ARM side, there is a gap there that resulted of creating these very focused specifications on problem areas like security or base firmware for OS boot that are OS agnostic, and that are, in most of the cases, they are not ARM specific, although some of them might be, but I would say the majority are not. And then creating open source test tools that are available in upstream. So these are not test tools that are specific to ARM. These are ARM contributions to open source UEFI testing. For example, UEFI has this test suite called the self-certification test, which ARM contributed these UEFI Secure Boot and TPM testing. It's in the process of upstreaming to that Tiano Core test suite. So what we are trying to say here is that there is no need to reinvent all of this if we already have the industry standards. We have the checklist of rules that are based on those standards plus practical industry implementations, and then we have the open source test suites that are being upstreamed with, you know, BSD licenses and all of that goodness. We already have a solution for this specific problem for DPUs. And on top of that, we have our own ARM System Ready certification program. OPI does not have to be necessarily, involved with the certification program itself, although a certification program is the umbrella that encompasses all the pieces here. But we have the specs and we have the test tools, and we are offering that OPI start from that rather than reinvent the wheel.
Yeah, go ahead.
All right, so just I think this is all great stuff. I'm not sure that it makes sense to tie any of this stuff directly to OPI. I think it's great. One problem that I have is with tying this directly into OPI is, yes, the majority of DPUs that are around today are ARM-based. It's not true for all DPUs, and it's probably not going to be true for all DPUs going forward either. And I think that the scope of this is larger than DPUs, right? Because this stuff could be applied to ARM-based servers as well, right?
Correct. But I understand that concern, Stephen, and I understand that this is bigger than the scope of DPUs and OPI. There are still ways to leverage this without getting out of the charter and the scope of OPI and DPUs, and without enforcing or forcing this on non-ARM DPUs if they exist. For one, non-ARM DPUs will mostly be able to leverage all of this as is if they are following the UEFI spec. Maybe the test suite that is upstreamed has not been validated on let's say I think that it builds on x86. I'm not sure how much it was validated on x86, for example. I'm just using x86 as an example, but it is there. It is open source. It should be possible to make sure that the test suite, the compliance test suite, build on any ISA. The UEFI spec, as long as that ISA is supported by the UEFI spec, then this collection of rules and the test suite that go along with it should apply. Now, if there are things here that are beyond the scope of OPI, maybe we call those out and we exclude them. So rather than just taking this as a wholesale from OPI point of view, we can pick and choose what makes sense for OPI and DPUs and reference them from these specs and point to the open source test suites instead of reinventing all of this.
Okay, I'm struggling because I feel like the majority of this is stuff between the DPU vendors and the OS vendors. It's not really something that affects like creating APIs for configuring the network, for example, right?
But true, but for example, Stephen, just a quick note, the boot synchronization is something between the DPU vendors and the server vendors. So from operating perspective, from OS perspective, you shouldn't care. So I don't think that if it's just narrowing the scope, I view that as a problem, right? It's okay to say that this is between distributions and the DPU vendors, and it's still in scope for OPI. I don't see a contradiction in this statement. Would you agree?
Kind of.
If you have 5 big distributions and they're struggling today with DPUs, and we can create a standard or at least adopt a standard, and all the DPU vendors will follow that, it will help the OS distributions, right?
Yeah, I'm just like I said, I'm struggling to see the strong tie between OPI and this, but I'll let it go.
No, that's good feedback. I'm not saying it's not a good feedback. It's a good question to ask. I'm just trying to see, like, in all these things, like what we actually do on those meetings, in addition to just going through the spec itself, right? Are we doing anything proactive? One of the suggestions, again, is to take the open source suite that Summer is talking about and maybe run them as part of our CI/CD or lab testing and publish the results. Is just one suggestion that I'm thinking to be more proactive. And if we see violations, for example, then maybe we can identify them and help the DPU vendors to actually correct them in the next generation or the current products.
I think it kind of goes back to the same point. It's not every DPU out there will be ARM based in the end. There might be things that are slightly different that have different chipsets or different architecture, and we shouldn't be excluding them. And it kind of also goes to my concern of signal noise. If we publish something behind this and say, here's what we expect, well, we're then being exclusionary in some cases, and also we're creating a lot of detail people are going to have to dig through for them to realize this doesn't really apply as long as the operating system is already sorted. It's more for those putting an operating system on the card. And maybe to put one more thought in this, there is value to operating system clarity, and that contract doesn't completely extend all the way to I'm trying to write an API to do a thing on a card to plug a network or plug storage or do whatever.
But
because
not all,
it's inside the context of the operating system on the card at that point.
I agree, but not all the work that we're doing is just exposing APIs, right? I absolutely agree. My concern is
if we have if we go, this is the standard, then who is that really applicable to? And how much does that require people to understand and comprehend for them to realize, oh, this doesn't really apply to what I'm trying to focus on at this moment? That's my concern.
Valid concern. Obviously, if we are adopting any of the standards, we will obviously put a disclaimer that this is applicable only if you are ARM-based, and if you have different specifications that can be applicable for other infrastructures and architectures, and we can adopt them as well. But for me, at least, just to give an example, if I'm developing an application on DPUs and I need to access all the different peripherals, in this case, like Summer is showing on the screen, for example, if I need to do some kind of work with TPMs and secure storage to store my private keys or whatever certificates inside, I want to have the consistent interface across all the DPU vendors. Or if I'm relying on root of trust of the DPUs and the secure boot to do some security operations, or maybe extended trust from DPU to the server, I need to make sure that this root of trust process was up to higher standards and doesn't have any violations in it, right? So we need somehow to be reassured that this works as expected correctly.
So then we're inherently changing the definition of going beyond lifecycle to operating system environment requirements.
But I think part of it was already getting there with, for example, the SMBIOS discussions that happened here before with lifecycle and provisioning. I mean, these are all things that impact provisioning. If you don't have the contract with the operating system on the device well defined, then you're going to have a hard time with the security lifecycle, with the inventory, with the updates lifecycle of the device. So at the end of the day, you do need some standardization inside the device with the operating system and the firmware to enable the seamless provisioning and lifecycle workflows.
And allow me to give color why this started with SMBIOS, right? So with SMBIOS, we were trying to just fetch a simple serial number of the device. And we realized that none of the DPU vendors provide the information in the same way for even a serial number of the device. So when we tried to develop any kind of applications based on that information, we realized there is no standardization in that space. So yes, operating system runs perfectly well, but if you're using the standard tool, whether it's UEFI variables or DMI decode or any other DMI tables, Linux interfaces with sysfs, whatever we want to use, we couldn't get the same information in the same way. So that was the reasoning why we started to look into SMBIOS validation tools in order to make sure that at least some basic information we can get from that. Same for inventory, like Summer mentioned, right? We wanted to make sure we understand how many CPU cores, memory, what PCI Express device is attached. So all of that, we wanted to provide the same inventory regardless what device we are querying. And again, we realized that there is very minimal standardization or missing fields or invalid values that operating system doesn't really care about what you put inside, right? The applications that running on top care. So when we developed the inventory protobufs, and we try to actually run those protobufs through the different DPU implementations, we realized that the information that we're receiving back is basically garbage. This is how at least the SMBIOS workstream started. So I was thinking we can extend that for security as well, because I remind you, one of the things that we developed or still developing in this workstream is secure zero-touch provisioning. So when secure zero-touch provisioning agent is running on the DPUs, it needs to access to TPM to fetch the device identities. So we wanted to make sure this can be achieved in the same way. And especially how ARM works with a normal boot process versus the secure ARM trusted environment. And all the different back and forth, I wanted to make sure that we all understand how that works. So the AZTP agent is an excellent example of touching on different points, running inside the DPU, developed in open source, and touching on different aspects that we found out that needs synchronization, something like that. Julia, Steven, makes sense? Yeah.
I think
Yeah.
it makes sense. I just think we need to frame it. Sorry, I interrupted you. Go ahead.
Oh, it's okay. So I said it before and I'll say it again. I think this is great work. I think this is work that needs to happen, no doubt. And I'll reserve further comments after I see an actual proposal to OPI for what's being proposed.
Julia?
I agree. I mean, my concern is more about framing and over the context of overloading ourselves versus providing clarity. So I don't disagree, is what I'm trying to say. I'm just trying to raise the awareness that we do have to provide clarity. We can't just roll everything together and say, here's our standard.
Yeah, and I agree with that. And I don't think the intention here is a wholesale just point to the ARM standard and saying we're done. I think the proposal here, at least first, there's no proposal. We're just reviewing the starting point that we have, so we don't start from square zero. And then we can figure out what makes sense and how does this fit in OPI as we get down to a prescriptive standard and the list of open source test tools to verify that standard. We don't have to take this wholesale, but we don't need to start from square zero from scratch either.
Okay, so I think if you don't mind, let's put a pin in it for today's meeting. I do want people to take an action item and think, this is great, and the ARM is doing great a job in writing specs and also open source tools. How is this applicable to OPI? This is what I'm hearing from Julia, Steven, and others. I think this is an action item I would like to kind of people think about, and let's revisit it next week on the face-to-face call. What exactly is a proposal to OPI? Like I said, there are several options. Just adopting the spec, pointing to the URL link here to this base spec and the enhancement for the secure boot. That's one. Running the actual open source tools on different DPUs and publishing the results. Different kind of ways about this. So I just encourage for people to think what they would like or feel comfortable with, having. Whether it's useful or not, and you can post it in Slack or hold it privately to the next meeting. So I think this is good, and we can maybe switch to the second topic that we had on the agenda with Daniel around the SM bias, which is relating to what we started to discuss as well. Sounds good?
Okay, thanks. Yeah, this subject is related to the verification tools. It's been mentioned. There are multiple verification tools available. So we are kind of looking for tools what can be used to verify what DPU is compliant with OPI requirements, future requirements. So this case is for tools what can be used to verify SM bias. So some background, there is a open issue for mandatory SMBIAS tables and fields, what should be available in DPU. Let me quickly share that. So there's open issue, and the reason for this issue, we may need to define mandatory SMBIAS tables, what should be populated by DPU firmware. Currently, we have tables what used by Marvell. Unfortunately, we don't have the fields under the table what required by Marvell. Maybe we can request additional details for that set of the SMBIAS tables. But we also is looking for like a NVIDIA and Intel SMBIAS tables what must be available, must be populated by firmware. So in order to verify those tables, we looking for like a verification tools what can do that, and we have suggestions, two suggestions. There are two tools what can do that, at least what we have right now. One tool is SMBIAS validation tool. And another one, it's firmware test suite, which provides DMI check, which also verify the SMBIAS tables and correctness of the fields in the tables. So, like it's been discussed, we need to choose what tool will work best for OPI case. So there is a spreadsheet available on Launchpad, which is shows the coverage of each tool. So this spreadsheet can be used to assess the tools and see if the required SMBIAS tables are verifiable by this specific tool. So let me quickly share the spreadsheet.
Daniel, before you share the spreadsheet, can you allow me to 1 second to share just a background for this, so maybe people can relate better to what we're trying to discuss here?
Okay, sure.
You able to see my screen?
Yes.
Yes.
Okay. So when we started to work on the different inventory issues, and this is example that we have on this page, recorded the examples from NVIDIA, Marvell, and Intel as well. So we record the examples of inventory queries that we implemented according to the OPI protobufs. So when we started to implement, we realized, I just wanted to show this one example. The serial number that is returned from one of the DMI tables is not populated. So you can see here unspecified system serial number. When we saw that, we realized that none of the existing tools or operating system or anything like that enforces the actual serial numbers on these cards. So we saw that a lot of people in the DPU industry are trying to work around the lack of a serial number in the DMI tables and try to pull through the different methods, whether it's VPD or something else. If you look into other things, you see a lot of unspecified information in other things. Versions may be incorrect, and different aspects of the DMI tables also kind of unmatching. If you look into the Marvell example, we see very similar picture to the inventory, but here most of the things are populated. So we realize there is no standardization and no synchronization that is happening in this space. If you look at Intel, for example, we see a lot of things are just missing as well. So what we felt that is needed in this space is some kind of standardization, but just publishing the standard was not good enough. So we looked into several open source tools that can help us actually running on every single DPU and IPU, checking the BDMI tables values and provide us with the exception list, what is actually not populated correctly. Whether the date, for example, is in correct format, or the field is missing or populated with not allowed value and stuff like that. I hope that makes sense for the kind of background why we're looking in this space.
Yeah, and Boris, I think from the GitHub discussion, and I'll summarize very quickly here, this is exactly what ARM is trying to do as well with the standard firmware interface requirements, that baseline and system ready certification and test suite. In fact, we have specific rules that say these SM-BIOS tables must be implemented and these specific fields must be implemented. And for example, serial number must be the valid serial number of the system. Now, some of these are very hard to test for, right? How do you know that a string is a valid serial number or not? We worked with the open source community that has been doing this type of testing, even on x86 servers and PCs for a long time. In UEFI Plugfests, there used to be these events, UEFI Plugfests, where people come with their machines and with their cards and software and try to do interoperability testing, and we find all these funny issues just because nobody tried to plug X and Y together and test if everything is working. And this tool, FWTS, was developed as part of that effort. If you look at that test tool, it has a quite big list of things that we have seen in the industry in the last 10, 15 years of invalid serial numbers, asset tags, and other types of default strings, like to be filled by OEM or XXXXXXX or not available, or 1, 2, 3, 4, 5, 6, all type of patterns like that. So if something is missing from that tool, we can definitely improve it. The community that owns it keeps it up to date with every new SM-BIOS release. They also keep it up to date with other industry standard consortiums that have specifications. So when ARM publishes our specifications, we simply point to our spec, and that open source community that maintains the tool, gladly adds more tests to cover the specs. If OPI decide to do something similar or leverage, so this is very similar to our previous conversation, it's all there. I don't think there's need for OPI to maintain our own tool and try to keep it up with SM-BIOS spec, rather than just use open source and leverage the community.
I don't disagree. What happened that with my quick search on Google, I found that Google is using something is called SM-BIOS validation tool, which is different from what Summer is talking about and Daniel. So I just cloned this repository into OPI. This is what Google is doing. So Google is basically checking all the different fields and all the different tables and show you exceptions, what is not compliant. And I was thinking this is a good way about it. And once Summer joined OPI, he showed me that most of this functionality can be achieved using the DMI check validation tool. I don't have a strong opinion, and Daniel wanted to show us the Excel spreadsheet between those two tools, pros and cons, so we can actually choose which tool to move forward with. Right, Daniel?
That's correct. Let me share
Go
the
ahead.
table.
Yeah. Go ahead.
One second. Find it. Okay. So can you see my screen?
Yes.
So this table is trying to outline the coverage of each tool. What is the common? What is the difference? So it has every type of the SM bias and has the data fields related to each type of the SM bias table. And it has the column for SM bias validation tool with marks which data fields supported by SM bias validation tool. As well, it has the column for FWTS, firmware test suite, and it has the column which indicates which fields are not supported by both tools. Also, during the investigation of both tools, I marked with green the fields, what data fields were supported only by FWTS, and in yellow fields were supported only by SM bias tool. So
Daniel, just a quick comment. I think that the exercise that we wanted to do is to take, like you listed here, all the tables and all the fields in the tables. And first of all, decide which are from this huge list are mandatory for OPI. Because I don't think we need to mandate all of them. And once we have the mandatory list on OPI, then we can match which tool actually verifies all the things that we want to verify that are mandatory.
Yeah, that's correct.
Yeah.
I completely agree. That was one of my comments for the issue, open issue. It has the SM bias tables, but it like from Marvell, but it's not really saying which actual data fields required in the specific SM bias table.
I think Marvell just posted what they support. It's not what they require. So we need to decide which fields are important and which we mandate, and then we can get feedback from different vendors. Do they support those fields or not, and what it will take for them to support those fields?
That's
Yeah,
right.
and I think what I would propose, and I commented on the GitHub, is we can start with the ARM SBBR requirements, which is the base firmware requirements for SM bias and the fields. And then maybe, and that's the one we test for the base firmware certification. Then maybe OPI can pick a subset of that, or if here in OPI we find something that we believe is required, but currently not required in the ARM baseline firmware, we can provide that feedback through the ARM specification and update the ARM specification if needed. But for OPI, we have the flexibility of requiring a subset, and for the test tool, we could even request, for example, if we go with FWTS, we could request that they add an OPI specific profile in that test tool that will test against the requirements that we decide on.
That makes sense, but again, the urgency and the highest priority is to take these tables and decide from these tables and the fields in those tables which are the most important for us to actually mandate, and then we can pick a tool that validates those. So I posted the link to the page that I showed previously, which is actually our inventory, current inventory information. Not saying it's a comprehensive one, but this is what we have so far. So the protobufs that we defined for the inventory, we have examples from NVIDIA, Marvell, and Intel that provide this information. So we can take maybe that as a baseline and start with those fields. But I think this work group needs to define the mandatory tables and mandatory fields in those tables, and then go back to the DPU vendors or work with them from the beginning in order to make sure that those mandatory fields and tables are actually implemented.
If you'd like, Boris, I could work with Daniil, and I could work and translate that link that you just sent and map them to this spreadsheet, and we can review that in the next meeting.
Sure. But I also encourage you, you know the DMI tables best, right? So you and Daniel, you can go through all the description, the C column here, type and offsets, right? All the different fields, and just propose, like mark those one that you feel are mandatory for OPI as a proposal, and then we as a group can kind of discuss it and vote that, okay, this is a mandatory field that we feel every DPU vendor must fill in the firmware.
Yeah, we could add that as another column as well.
A proposal, what we mandate, and then we can review it. Yeah, makes.
Okay, that makes sense.
Julia, Steven, others, like any comments on this? Is this different from what you kind of commented before? This is much more clear. What are your initial thoughts on this?
I have no additional comments on this. I agree, Boris, with what you said our goal is. It makes sense.
All right, with that, I think we're out of time today. So I would like to thank Summer and Daniel for presenting. The link for this table is available. Daniel, maybe you can also share it in Slack so people can review it offline. And next week, if you're ready, Daniel and Summer, we can start reviewing the mandatory fields in addition to continue other topics that we posted in Slack as agenda items. Thank you, everybody, for this week, and see you next week.
Thanks.
Thanks.